like to welcome everybody to today's webinar hosted by Innovative Health. We will be discussing the environmental benefits of reprocessing and how reprocessing fits into the circular healthcare economy. The webinar that you have joined is non-promotional and complementary. We do this to move the sustainability agenda forward. We are also recording the webinar so it can be accessed after we're done today. I'd like to thank everybody who has joined so far and those that will be joining here in a minute. We have quite a few folks actually signed up, as mentioned. We would like to have an open dialogue about the topics today. They're important topics. So we'll, at times we'll ask for questions. And we do ask that when not asked for questions, please keep your microphones muted so we can avoid background noise. The presentation will be about 30 minutes or so, and then we'll have time for questions afterwards, as well as a few times during the presentation. What we'll go through is these things. This is what we have on the agenda. Most people know that single-use device reprocessing offers environmental advantages. It's intuitively so, and we will go through this and focus on the impact of this activity in healthcare. Then secondly, we'll discuss a new study that shows exactly how big this environmental advantage or impact of reprocessing is. And thirdly, we'll be discussing how reprocessing fits into the circular healthcare economy. Hospital staff, administrators, and lawmakers are increasingly talking about this, and so it's high on the agenda. Fourth item, as a consequence of that and the results of the new study, we have calculated EP reprocessing environmental savings in the United States, and you'll be looking forward to that. That's interesting results. Finally, we will be looking at what a reprocessor can do to even further reduce the impact of medical device use on the environment. I have two presenters with me. Anna Schulte from the Fraunhofer Institute in Germany. She was the lead author of a recently published life cycle assessment of reprocessed EP catheters. And secondly, I have Sean Essex, who is the head of lean manufacturing engineering and environmental spokesperson for Innovative Health. And I have the honor of moderating the session as we go through this. But first, a little bit of context. The pandemic certainly has led to a focus in hospitals on the need to reuse some medical devices and emphasize the need for hospitals to critically review their supply chain. And that was further emphasized when, during his very first days in office, President Biden actually honed in specifically on the healthcare supply chain as an area that needed improvement. And meanwhile, U.S. hospitals obviously during the pandemic experienced losses of millions of dollars due to massive slowdown of revenue generating non-emergency procedures and steep declines in patient volume in general. And some of them are still experiencing these losses. They understand that financial sustainability comes with fundamental changes to the way they buy and the way they use and don't reuse medical equipment, pharmaceuticals, and other types of supplies. At the same time, the new administration has indicated, and this is the other prong, if you will, to the circular economy issue, the administration has indicated that it'll have a strong focus on environmental sustainability. The United States is very clearly lagging behind most other first world countries when it comes to systemic reform to reduce unnecessary waste and greenhouse gas emissions. And this likewise is high on the administration's agenda. I believe that taken together, these factors will mean that 2021 will become the year where a circular healthcare economy will become a vital discussion in the United States. To give a little bit of an illustration of the size of the problem we're trying to tackle here, last December, the journal Health Affairs concluded that the health sector is responsible for 4.6% of global greenhouse gas emissions, and that, quote unquote, the vast majority of healthcare global greenhouse gas emissions originate in the supply chain. The problem we're tackling is a huge one surrounding medical device utilization, and its solutions have to be fundamental. I'll hand the microphone now to Sean Essex, Innovative Health's environmental spokesperson, who will put a lot more color on this.
Thank you, Lars. So in a traditional healthcare economy, we take resources from the environment, we make the devices, we use them in the hospital, and then we throw them away. So why do we do this? There are three primary reasons why healthcare follows this model. First, healthcare is a single-use mindset. So it's safer to throw away a device after they've been used. Second, it is difficult to reuse devices. They have to be collected, cleaned, tested, sometimes sterilized before reuse. It's much easier to throw the device away after a single use and grab a new one. Third, the industry that manufactures devices has discovered that single use means the hospitals buy more. So by designing devices for a single use, the manufacturer maximizes its profits. So current economic and supply chain pressures on healthcare have shown that this model is not sustainable. It costs too much, it's bad for the environment, and when demand goes up, such as for certain types of products during the pandemic, supplies can't be found. So single-use device reprocessing challenges the single-use mindset in healthcare. Effective systems are in place for collecting the used devices. The process for making the devices ready for another use is FDA controlled, and devices seamlessly go back to the hospital for another use. Reprocessing is an established circular economy solution. In fact, it may be the only circular healthcare economy model that is successfully used. So in a circular economy solution, devices are not thrown away after single use. Instead, the manufactured products flow in loops throughout the system, cascading through cycles of reuse, reprocessing, repair, repurposing, and recycling. This maximizes the value and minimizes waste disposal. So in reprocessing, used devices are used as resources in a secondary manufacturing process called reprocessing, and then used again. Sometimes devices can be reprocessed more than once. And after reuse, devices are collected and parts from these devices can be recycled. How does this all work? Medical devices labeled single use by the manufacturer collected after procedures or other uses and stored. The reprocessing company's representative picks up the devices, ships them to the reprocessing plant. Here they are traced and registered, cleaned and tested and sterilized. And then at this point, the hospital can purchase the reprocessed device for a fraction of the price paid for a new device. And then, as I mentioned earlier, after reuse, devices are collected and parts from these devices can be recycled. I think most importantly, to note, it is all FDA regulated. So the reprocessors can only perform these services after receiving a device-specific clearance from the FDA and demonstrating that the reprocessed devices are functionally similar to new devices and don't present any added patient risk. However, so single-use devices, single-use device reprocessing does more than save hospitals money. It also helps the environment, and it makes the supply chain more resilient. Single-use device reprocessing provides important cost savings to hospitals in the United States. Hospitals are saving more than $400 million per year through the use of reprocessed single-use devices. Innovative Health works with the electrophysiology labs to reprocess their electrophysiology catheters and other devices. In fact, some hospitals are saving more than $1 million using reprocessing in the electrophysiology lab. And this is one of the biggest areas for reprocessing savings, which is in cardiology. So where US hospitals are saving combined $800 million per year. Again, some US hospitals save more than $1 million per year using reprocessed devices in their EP lab. However, these savings, the savings potential is far from being fully realized. Some estimates suggest that US hospitals could add $500 million more in savings by fully leveraging reprocessing. Current utilization of reprocessing has resulted in substantial cost savings for hospitals, but more importantly, solid waste from US hospitals is reduced by more than 6,000 tons. But reprocessing means transporting devices, using chemicals to clean them, and transporting them back to the hospitals. These are all activities that have an environmental footprint. So how much better is a reprocessed device when actually compared with a new device when it comes to the environment? Well, it turns out that reprocessed electrophysiology catheters have an environmental impact that is less than half of the impact of a new device. So a recent study by the Fraunhofer Institute for Environmental Safety and Energy Technology found this result. It was published earlier this year, January 17, 2021, in the journal Sustainability. Now, this study shows the difference in global warming impact. Although electricity and detergents are used in reprocessing, the impact of plastic production and other things on a new device make reprocessed devices much less environmentally harmful. So at this point, I'd like to ask if there are any questions. And if not, then I would like to introduce Anna Schulte, the lead author of this groundbreaking study. Anna, can you please share your screen?
Yes. Does it work?
Yeah, put it on full screen mode, Anna.
Okay. Okay, thank you. That was actually the perfect introduction for an easy way to get into the topic. Now I think it gets a bit more scientific, but I hope you can follow. My name is Anna Schulte, and today I will answer the questions if medical remanufacturing can save resources and greenhouse gas emissions and how this contributes to circular economy. But let's do this step by step. And at first, I would like to point out that within my presentation, medical remanufacturing actually means reprocessing. However, in Europe, we rather focus or we rather use the term remanufacturing, which you can find in the study and the presentation, and it's defined as returning a used product to at least its original performance with a warranty that is equivalent or even better than of a newly manufactured product, according to British Standard Institution. Now I will give you a short picture of who I am and what I'm working on. This work is part of the Fraunhofer Cluster of Excellence, Circular Plastics Economy. And the cluster has the purpose to bundle competencies of 6 Fraunhofer institutes in Germany, shown here, along the value chain of plastics. And the cluster is subdivided into 6 research departments. So the cluster develops new circular polymers, additives, compounds, works on alternative recycling technologies, circular logistics and sustainability topics, as well as cares for prototyping and circular business model transformation. And I'm actually a PhD candidate at Fraunhofer Umsicht in Germany, and I'm assessing products in the context of sustainability and circular economy. And we proved that medical remanufacturing or reprocessing is a good example for circular value creation, and I would like to tell you now why. We deal with questions such as how to prepare a product for the circular economy, how to assess these products such as single medical devices, and how to gain more transparency and decision support. So looking at the value hill framework, you can see that from cradle to gate, so the pre-use phase, value is edited up to the point where the product is over the counter. And after use, the value is destroyed unless we apply strategies to retain or perceive this value. And according to the value hill principle, strategies such as reuse and remanufacturing can perceive more value compared to recycling, where only the value of the material can be perceived. And it follows that we should apply strategies closest to the user. I'm very sorry. And for those who are maybe not familiar with life cycle assessments, I will give you a short introduction. LCA follows a 4-step approach. At first, the goal and scope phase is applied, defining the system boundaries and the so-called functional unit, which is a reference unit. In which the environmental impacts will be accounted to. And then the inventory data is collected, so input and output data. The impact assessment, which is the 3rd phase, can observe different impact categories calculated by different impact assessment methods. So we used here the so-called environmental footprint method, which is recommended by the Joint Research Center. The interpretation phase is actually the fourth step, but it's actually relating to all previous steps. And in this case, we did a contribution, sensitivity, and circularity assessment, but I will proceed later on that. To classify the novelty and the research gap, medical remanufacturing might be the most promising circular strategy, as also mentioned before, for single-use medical devices, because they cannot be reused easily nor recycled. And we did not found an LCA so far in the sector of medical remanufacturing. Our research task was to investigate whether medical remanufacturing can reduce environmental impacts and contribute to the circular economy principle. We were able to demonstrate this using the example of an electrophysiologic catheter in a commissioned case study by the Vanguard AG in Germany. I published this in the Journal of Sustainability. The publication analyzed the environmental impact of remanufacturing catheters compared to virgin production. And the case study, we examined two modeling perspectives, a common LCA perspective and a combination of LCA and circularity indicators, and placed them side by side. The approach with the circularity indicator is not intended to replace common methods, but to complement the depth of interpretation. And both perspectives have the same functional unit, so they are comparable in producing a catheter, but they differ in some points. While the common approach provides information on the environmental impacts caused by the use of a product, so over a single life cycle and thus over a short time horizon, the circularity method here provides information about the environmental impacts caused by the establishment and collection of a remanufacturing system. The system is extended and the entire pathway of the product is assessed considering multiple product life cycles on a longer time horizon. And thus a system comparison between linear and circular becomes possible. In order to understand that, the modeling and the process system, I will maybe explain a little bit. The system boundaries in the common approach are shown here. In the virgin production, the system boundary of the catheter is produced from virgin material, then transported to the customer, and after use, it is disposed and treated as waste, incineration in this case. And then a cutoff is placed. For the medical remanufacturing, we started with a collection of catheters as burden-free product, which are then transported to the remanufacturing process, consisting of an identification, sterilization, inspection, sterile packaging, and final packaging step before the product is also transported to the customer, and then the loop is closed and a cutoff is placed. Building on this principle, we then integrated a circularity assessment. But why do we need this perspective in LCA? Circularity and sustainability are closely linked, but they can also contradict each other. We want to provide decision support in order to find the circular solution that is most sustainable. So closing the loop up to the point where we have the best environmental benefit. We combine the established LCA method with the circularity indicators in order to identify these solutions. And we apply a product or material tracing perspective. A common approach is comparing two different production single routes, for example, virgin production versus remanufactured product. And however, on a system perspective, both product systems need to be observed as a pathway, and therefore we need to understand how often a product is passing a specific loop. And we are then comparing different systems in order, and we take into account circular actions that are applied to this system. For those who call for formulas, I've also noted down the formula, but for those who cry because of formulas, I will skip that for now. To sum it up, we are measuring environmental impacts from all loops along the value chain and mirroring life cycle thinking. Integrating this perspective into the system boundary, this means that we have a linear production here where all catheters are produced from virgin material and then disposed, resulting in a circularity of 1, which means that the product and the product system is fully linear. The circular production perspective includes a full collection of the catheters for remanufacturing. All catheters are collected and then remanufactured according to the previous mentioned steps, and then entering a second use stage. Those products can be remanufactured again and again until the product is discarded due to failed identification. The resulting circularity is 2.09, which means that every catheter is used on average 2.09 times. After we have managed the theoretical background, we move to the more interesting part, the results. At first, the results of the commonly used LCA approach will be presented. We prove environmental benefits in 13 out of 16 impact categories evaluated with more than 20% savings from medical remanufacturing compared to virgin production per catheter. Environmental drawbacks were calculated for eutrophication, fresh water, land use, and water scarcity. Here, further research is needed. The focus was set on global warming impact, which is represented by climate change, and abiotic resource use, which is represented by minerals, metals used here. And here, global warming emissions were cut about the half when using a remanufactured catheter. And for abiotic resource use, a saving of 28.8% were calculated. To keep it short, we here only have the results of the global warming impact, and the common LCA results prove these 50.4% savings when using a remanufactured catheter. For virgin production, the main contributor is the plastic production and processing, and for medical remanufacturing, the main contributor is the use of electricity and waste treatment. The LCA results with the circularity metric show that the circular production system representing multiple product cycles due to remanufacturing on a long-term perspective show also benefits. This approach could provide information for policy and other decision makers as it shows the transformation potential from linear to circular. And that means that in a fully circular production system, a carbon footprint could be reduced about 34.5% compared to linear production system. Assuming that approximately 750,000 ablation catheters are used every year in Germany, a full collection of catheters and remanufacturing according to the explained process, 450 tons of CO2 equivalents can be saved per year, only when collecting and remanufacturing these catheters. The results suggest that remanufacturing as a strategy has major impact. In reality, of course, the reality is between fully linear and fully circular systems, and therefore the collection rate was varied in the figure on the left. The results shows that saving per catheter increased slightly exponentially with increasing collection rate. For example, if 20% of all catheters are collected, a saving of 5% is realized, compared to zero collection. Doubling the collection, however, slightly increased the saving to 11%, and if a straight line is then drawn, the effect becomes maybe a bit more clearer. The more is collected, the more can be saved. And that's why we need to apply a system, a remanufacturing system, and not only try to remanufacture as many catheters as possible. Assessment methods are definitely needed here in order to prove evidence. Ending with my take-home messages, circular value creation claims to be both environmentally and economically beneficial compared to linear value creation. Medical remanufacturing or reprocessing of single-use medical devices is an excellent example because it has the potential to perceive the product as the highest possible value instead of recycling. It is circular and reduce environmental impacts compared to virgin production and reduce environmental impacts on a system perspective. A legal obligation for medical remanufacturing or reprocessing for medical devices with a remanufacturing potential could be a key to circular economy and more sustainability in the healthcare system. And with that, I'd like to thank you for your attention so far, and I'm open for questions later or now.
So thank you. While Anna takes her shared screen off and we put the next section on, are there anything that anybody wants to ask Anna? That was very insightful, very professional. I appreciate your participation here. Anything that anybody wants to ask Anna?
Anna, just a quick question. Good job. Thank you for the explanation. That was very informative. I'm a little curious to understand the catheters that you looked at. Were you looking at a range of catheters in terms of surface areas and weights and different material composition? I saw the photograph you had one of the very specific model. Was that the focus there, or did you look at ranges as well from different manufacturers?
No, for this study, it was just a specific catheter, as this was the product we had to investigate, and as the results were so good. So it started as a typical industrial project where a company asked us for assessing the environmental impacts, and then it turns out to be that great. And then we decided together with the company to publish the information in a peer-reviewed journal. And I think maybe a next step could be then to look at product ranges or product sectors in this field.
Yeah, I think the reason I ask is because, within this technology space, the catheters do get larger in size. Some of the more complex imaging catheters do offer, a lot more surface area, a lot more plastic. So maybe a continuation could be looking at the greater impact of some of the bigger devices out there.
Yeah, definitely.
Very well done. Yeah.
Good question. Anybody else?
Hi, Anna. My name is Heidi Brelsford, and I wasn't able to see your screen, so you may have covered this on the screen, but I have a question about what your feeling is regarding what motivates a system to switch from a linear to a circular. Is it primarily the financial motive of, saving, like you said, about 50%, or is it the environmental motive? Is there, maybe there's some sort of regulation? Is there any government credits, tax credits that systems get for switching, or legal mandates? I'm just really curious about that process.
Yeah, very good question. I think it's also different in different countries. I think for most companies, in the end, it's an economic aspect if they can make money by looping products. But it's also, or even here in Europe, the environmental aspect is becoming more and more important, and the regulation will definitely change in that case. And also a lot of startups, smaller businesses start to come up within the last 5 years and make money with sustainable solutions. So I think there is a system perspective changing right now. I'm not so much into the system thinking or the life cycle thinking in America so far, but here in Germany or in Europe, I definitely see a system change, and that environmental benefits become more and more important, and that also companies have to think of where there are maybe low-hanging fruits which they can harvest in order to make money and be sustainable. And also there's the other perspective where companies evolve by being sustainable and participate and getting customers that are built on sustainable principles in order to participate and fulfill the sustainable development goals.
Thank you, appreciate that.
That was a great question, and I'd like to provide a little bit more color because Anna respectfully points out that she may know less about the United States and motivation here than in Europe. I think a big difference is, the term circular economy has been established in European discourse and European political systems for a while. It's only now emerging as a term widely used and a topic widely discussed in the United States. So I think that there's a little bit of a lag there. And certainly a difference in the United States is possibly when the question comes to motivation, that the environment typically means a lot less than the cost savings opportunities. But I do think, to my point earlier, that we have a situation today with societal events and discourses sort of experiencing a confluence between cost savings and environmental benefits. So we have two different motives, environment and costs, that these days are driving the same behavior changes. And I think that the pandemic and increasing awareness of maybe I shouldn't throw this device away right away is creating again a situation where two different sets of motivations are creating and driving the same behavior changes, and they feed off of each other, I believe, to escalate the importance of the discussion about circular economy, which is a great thing. we have two different interests that are being served at the same time. It's up to lawmakers and decision makers in the United States to make sure that this is actually reflected in the appropriate changes to how we regulate and control how healthcare manufacturers are acting around these matters. So.
And then Lars, could I just add a follow-up question really quickly?
Absolutely.
Have you seen any movement legislatively regarding maybe any talk or any movement at all regarding perhaps offering tax credits or corporate credits or some sort of incentive towards reprocessing or legal mandate within a large system like the VA or Medicare or something like that?
So we have not, and it's inherently un-American to do so. Said with a smile on my face. I believe that this type of behavioral change in healthcare will come about because gradually corporations inside and outside of healthcare, institutions inside and outside healthcare will volunteer to do this because it makes sense from a profitability perspective. Anna was talking a little bit to that as well. But when you have a confluence of environmental and cost savings initiatives, that's what will drive the attention to becoming less wasteful. In fact, we have seen, of course, again, the Biden administration providing all sorts of signals about more emphasis on this, but we're still lacking, you're mentioning VA, legislation, regulatory implementations that reflect this new mindset. I do believe it's a matter of time.
I believe it's a matter of time as well, because we have no choice. We have to start talking about sustainability, and reprocessing is really key for reducing medical waste. Thank you so much.
No, thank you. Anything else from Anna? Loving it that there's some dialogue.
I just totally agree. It's just a matter of time. I think 5 years ago here in Germany, it was maybe rather a marketing or a buzzword or an umbrella term, but it turns out to be the pathway everyone follows now, and how companies completely change their mindset and being sustainable and circular, and at the same time identifying environmental and economic benefits. And that's basically a very good thing, isn't it?
Exactly. Okay, thank you again, Anna. We understand, we had the question before, is this one device, is it several devices? EP devices have different weights, right? And but the interesting question, of course, now is that on the heels of Anna's results, what is the impact of reprocessing in US healthcare, specifically in the electrophysiology space? And Anna, if you will stop your screen sharing, then we'll pop up the next few slides that we'll discuss specifically what is the impact. I'd like to emphasize that we've done these calculations based on, again, the Fraunhofer study, which is based on one EP device, and they do weigh differently, and estimations and projections done by different institutions in the United States. But what we believe is and we've used a weighted number of how many devices are used in different types of EP procedures in the United States. And if you do that, there's a total of about 3.4 million EP devices used in the United States every year. And with an average weight of these devices, and to the question before, we actually do take into account the fact that some devices weigh more than others, that would mean that in the electrophysiology space, a total of 4,762,000 pounds of waste is generated from EP procedures. About 1.6 million of this is currently being kept out of landfill because of reprocessing activities, which, and this is sort of on the amusing scale, is equivalent to the weight of 345 elephants that is currently being thrown into the landfills because EP devices are thrown away rather than being reprocessed. A little illustration there for you. As for global warming impact, Anna touched on that as well. Based on the Fraunhofer study, and published numbers about volume of EP procedures in the United States, reprocessing has the ability in this space to reduce global warming by 940,000 pounds per year. So, Sean.
Yes, sir. Thank you, Lars. Excuse me. So hospitals can do many things to reduce their environmental impact. But as you see, by using reprocessed devices instead of new, they can immediately reduce the impact by 50%. And I think everyone here at Innovative Health is proud of being a part of that. However, at Innovative Health, we believe we can reduce the environmental impact of the EP lab even further. So as lean manufacturing engineer, I participate in every design process right from the beginning. And my job is to make sure we avoid waste and reduce resource consumption as much as possible throughout our operations. So some of our most recent initiatives to further reduce environmental harm are as follows. First, reducing waste. We are actively looking into alternative cleaning agents that are not only effective, but also environmentally friendly. We are now investigating an EPA registered cleaning and disinfecting agent that kills 99.99% of all bacteria and viruses, yet breaks down into water and other organic components naturally in a short amount of time. So this will eliminate environmentally harmful chemicals used in our cleaning process, and it will reduce the amount of water used by 61%. Second, saving energy. We continually are reviewing and improving upon our cleaning process for two reasons. First, we want to make sure our cleaning process is effective and consistent. Patient safety is our primary goal. Second, we want to make sure we're not over-processing the product and using only what is necessary to achieve our strict standards of cleanliness. Innovative Health is currently working on another project that will optimize our current cleaning process, reducing the amount of environmentally harmful chemicals by 12%, and again, reducing the amount of water by 58%. Third, reducing product rejects. By reducing reject rates, less resources are wasted and more materials are kept out of landfills. In the past year, Innovative Health has reduced the reject rate of two of our leading products by 13% and 8%. Reducing rejects is a never-ending initiative here at Innovative Health, and additional projects are underway to reduce the reject rate for other leading products. Fourth, reducing resource consumption. Through additional validation activities, Innovative Health has been able to reduce the water consumed by 50% and the energy consumed by 33% at our final rinse step. This is just yet another example of how process improvements can positively affect Innovative Health's environmental impact. Fifth, reducing overproduction. And I think this is the first waste in lean manufacturing. But when a facility produces more than what is in demand, physical space is required to store the excess product. If the product expires, then resources consumed to reprocess that product will waste it. At Innovative Health, approximately 98% of what we manufacture has immediate demand. So this allows us to reduce the resources needed to store excess product and keeps waste out of landfills. Finally, our packaging design. So our dedicated packaging engineers are involved in the design process from the very beginning. Their task is to ensure that each packaging solution has the lowest possible environmental footprint while protecting the device. If the packaging cannot protect the device cannot be reprocessed, and the positive environmental benefit is lost. For example, we reprocess a diagnostic ultrasound catheter that can cost as much as $2,500 or more from new. When sending it to the customer, it must be properly protected in a backer card and carton. We looked carefully at standard manufacturing packaging and determined that we could reduce the number of square inches of packaging material by 26% compared to the new device. So this means 26% less carton is used and 26% less inside protection material is used. And these are the initiatives that make a difference.
Thank you, Sean. Thank you again, Anna. Very informative. There's a bar that needs to be continued to be pushed here, Sean, and I appreciate what you're doing in reprocessing to help that happen. Any further question? I guess before that, I do want to call out Vanguard the reprocessing company, the leading reprocessing company in Europe that initiated this study and has helped to put reprocessing as a circular healthcare solution on the top of the agenda through the company's collaboration with Fraunhofer Institute. This is something that I think that we all should applaud. It's very important. So I did want to call that out. Any questions here before we end our webinar? Excellent. I thank you for not only listening in, but also engaging in dialogue around this. I believe everybody on this call recognized the importance of these matters, and also possibly can see how reprocessing can not only contribute to our efforts to reduce environmental harm in healthcare, but also become a little bit of a template for how other environmental initiatives in healthcare can help us with those purposes. And with that, I will end the webinar. Again, the webinar has been recorded and it'll be made available on our website. So if you liked it and you know anybody that didn't have the chance to participate, please point them to that. Thank you all.